Good morning, good afternoon, or good evening, everyone. My name is Evgeny Shapira. I'm the product manager for fluids at Realis Simulation. Thank you for joining us today for this presentation of the new features in Wave and WaveRT in our first release of this year. In the presentation, we will explore numerous enhancements which we have introduced in this release across functionality, user experience, and workflow categories. To start with the functionality, in this release we have significantly refined our predictive combustion model by adding a new laminar turbulent transition model following the work of Herwig and Mali. This model improves the accuracy of the prediction of the initial stages of flame propagation. Also, the predictive model is now fully compatible with the stratification submodel. Specifically targeting rotary engine applications, we have introduced features which enable modeling of leakages that might occur through the spark casing and between the lobes. In terms of user experience, for WaveBuild 3D, our preprocessor stability has been a key focus area, and we also have improved user experience when working on complex models and the speed of component merging for components with valves. Additionally, in RDesk environment, there are new visibility controls in the case table, which allow for quicker identification and inspection of specific parameter groups. Customers moving from WaveBuild WavePulse legacy GUI to our RDesk environment will also find a significant improvement in workflow through the new direct data access feature in our post-processing. In RDesk, we have aligned parameter units handling between WaveBuild and RDesk, ensuring consistency for the models imported from WaveBuild environment into RDesk environment. The model optimization tasks are now much faster in terms of the setup due to the new auto-import and auto-connect functionality in RDesk Tuner. The session difference tool features a number of enhancements, offering a more streamlined workflow. Finally, we should mention two important licensing changes in this release. For desktop applications, we introduce Reprise License Manager as a replacement for FlexLM. This change, combined with the improved license configuration panel and support for user profiles, provides our users with a better flexibility, allowing seamless usage of on-premises and cloud licensing options, as well as better management for multiple licenses. Also from this release, WaveRT Heal applications become not locked to customers' Heal machines, improving security of WaveRT delivery. In the coming sections of the presentation, we will delve deeper into the highlighted features and provide a more comprehensive understanding of how they can enhance your experience and your workflow with Wave and WaveRT. So let's explore what these updates mean to you in practice. Let us start with the improvements in the SI predictive combustion model. The challenge we're trying to address here is to enhance ability to accurately capture effective ignition delay. Effective ignition delay incorporating the transition from laminar flame to a fully turbulent flame. To address this challenge, we're introducing a new submodel for predictive combustion based on the work by Herwig and Mali, and the model provides the description of the laminar turbulent transition by modifying the effective turbulent flame speed and providing a smooth blending from the fully laminar state at the start of the spark to a fully turbulent state as the spark kernel develops. The flame speed then varies and this variation reflects the ratio of the flame kernel radius to the turbulent length scale and the ratio of the time from the start of the kernel development to the turbulent time scale. One of the advantages of this model, which is available in RDesk and SI predictive combustion model panel, is its tunability. Users have control over the duration of the transition through the multipliers on the radius and the time scale, and this allows, particularly in the concept of predictive model tuning in RDesk Tuner, effective targeting of the early stages of combustion, for example, of the 10-degree burn angle. The figure here shows the variation of the fuel burn rate with the transition model off and transition model on, and different values of the kernel multiplier and the timescale multiplier. In addition to this development, we also have enabled stratification model with SI predictive combustion, so these two models now are fully compatible. And this integration helps our customers to represent incomplete mixing and charge distribution more effectively and accurately for direct injection applications. Our next feature originates from our focus on streamlining workflow processes and enhancing users' productivity. Post-processing tools such as our post, they play a crucial role in analyzing, visualizing, and interpreting simulation results. However, users don't always need to actually see the plot of the data. Sometimes, for example, a quick check of pressure drop, it is more convenient to look at the actual values, and it's faster to look at the values directly on the simulation elements without having to plot the data either in the form of plots or in the form of contour plots. In this 2025.1 release, we introduce a new enhancement in our post that makes data inspection faster by enabling data viewing without plotting. Users can access the data, summary data, instantly from the context menu of any element, either from the main canvas or from the object tree. Let's have a look at an example. So here is a sample for cylinder engine with a number of flow elements, ducts, wire junctions, cylinders, and other elements. And if we right-click on an element on the canvas or on an element in the object tree, there's a new item, View Summary Data, and clicking on the Summary Data item brings up a table showing the actual values of the summary data on this element. For example, for ducts, the most important summary items are displayed initially, such as pressure drop of the duct as pressure on the left and pressure on the right, temperature on the duct, temperature on the left, temperature on the right, and the flow on the duct as a table for each case of the simulation. Users have access to all the summary variables on the duct, which can be easily enabled or disabled. And also users can see all the elements of this type, in this case ducts, in the model and actually compare the values on them. Finally, it's possible to easily export the data either to CSV format or to Microsoft Excel. This update improves efficiency by providing our users with the freedom to analyze the data in a way which best suits their workflow and reducing reliance on a full visualization, which makes our post an even more powerful tool for data analysis. In this release, we have also added support for dimensionless unit handling in our desk. The objective here is to facilitate transition from WaveBuild to our desk for existing WaveBuild sessions, as we're seeing users migrating more and more from our legacy GUI to the new GUI. The solution here is to enable treatment of parameter units as dimensionless by default when evaluating complex expressions in our desk, effectively the same type of expression evaluation as used in WaveBuild, which means that sessions which are imported from WaveBuild into our desk featuring complex expressions involving parameters do not require any modifications anymore. This new treatment of parameter units is an optional preference enabled by default and available in user preferences in our desk. The example here shows a typical injection duration modification where we're specifying injection rate profile with a ramp at the beginning of the injection and at the end of the injection. In previous releases in our desk, such a specification would require injection duration parameter to be dimensionless. In this release and in the following releases, the injection duration parameter can have dimensions such as degrees, for example. Continuing with the subject of workflow improvements, let's have a look at the new features in the Session Difference tool. The session difference tool was introduced in 2024.2 and it was designed to address the challenge of saving time during model development and troubleshooting. What it does, it simplifies the comparison between different model builds which occur, for example, as we're progressing through the validation stages of a 1D engine model or through modifications of the engine in an actual project. In this release, we have added a number of changes in the session difference tool based on the feedback on the first release. So, for example, here we have two engine builds which differ in terms of the tuning of various model items of turbocharger, catalyst, and charge air cooler. And the first thing our customers will notice is that the session difference tool has a new look and feel. It is possible now to swap comparison around. The settings are in a collapsible, which allows users to maximize the screen space for complex comparisons where there are many differences between the sessions, between different builds. There's also a new tolerance option, which allows us to include or exclude small changes for real-valued numbers. For example, changes arising from round-off of test data. When selecting the target for comparison, it's now also possible to pick up a session which is already open in our desk, which makes comparison much faster than loading a session from disk. And you can see that the look and feel of the tree is now exactly the same as the look and feel of the tree in the session, which simplifies visual interpretation of the location of the differences. It's very easy to navigate to the item which has changed by using this looking glass icon next to the item, which brings us to the item in the model. And finally, this tolerance allows us to exclude small differences. For example, here there's a difference highlighted in the case table, but the difference arises from a round-off of the ambient pressure, which can be excluded by resetting the tolerance. Collectively, these small enhancements streamline the comparison workflow and ultimately save our customers time during model development. Workflow enhancements in this release continue with their changes to the optimization workflow. Optimization workflow in Wave is based on our desk tuner, which is a Realis Simulation optimization tool based on circuit optimization, which provides extremely powerful environment to fine-tune your models, calibrate your models, including predictive models, leveraging the power of surrogate optimizer. The workflow, which is used to construct optimization process, be it for Wave models or for WaveRT models, in our desk starts with packaging the model as a self-contained unit. For a Wave model, that will be an FMU, which is created by the FMU expert task, and for WaveRT, that would be an RT model, a shared object created by a WaveRT expert task. The enhancement in 2025.1 release in this workflow now allows users to import all inputs of the tuned model defined by parameters and automatically connect them to parameters which are already present in the session. Let's have a look at how it works. For example, in this session, we have a diesel engine which has been configured for predictive combustion. And typically, predictive combustion models require some calibration. So in this case, diesel predictive combustion model is used. And the quantities which we normally advise our customers to tune for this model are exposed using parameters, for example, diffusion multiplier, turbulent speed exponent, and retarding exponent. For the purpose of model calibration, the model is then packaged as a self-contained unit using this FMU expert task. And FMU expert task exports all the parameters which have to be driven externally when the model is optimized. So here we can see the parameters of the diesel predictive model itself, and also parameters of the injection and engine RPM. The FMU tuning task then in 2025.1 provides this new button, Import Inputs, and what this button does, if you click on it, it automatically finds all the parameters in the FMU and auto-connects them with the parameters present in the session and populates the operating condition table. So this provides the baseline for the tuning exercise, and then if we want, for example, to tune retarding exponent, we can delete it from the operating condition and enable it as a tuned parameter instead. For complex models which feature tens of actuators, sensors, and parameters, this mechanism provides a quick way of populating the inputs of the model for the RDES tuner, and also minimizes possibility of mistake when connecting parameters of the tuned model to the parameters present in the session. Exactly the same approach works for the real-time model tuning, for the WaveRT tuning task. So overall, this improvement reduces the time required for the setup of the tuning exercise, both through automatically populating the connections and through reducing the possibility of mistakes in making connections between the tuned model and their data defined in the session. The next usability enhancement adds new modes of navigation for the case tables. Particularly, this can be useful for case tables featuring hundreds of parameters, which is quite typical for our customers using Wave and WaveRT for virtual calibration, where the case table can contain not only the parameters of the model itself, but also, for example, test data, which is used as targets for the model tuning. To simplify working with such large case tables, we have added new filters to the case panel. For example, going back to our GDI engine, users will notice the 4 new filters. The first filter allows you to hide read-only parameters. The second filter hides unused parameters. Third filter allows you to show just unused parameters. And finally, the last filter hides constants, so showing only parameters which are actually varying between the cases in the session. These filters can work together, and they are providing an easy way of presenting a custom view of the case table, which can be particularly useful for large case tables. Our post, our visualization and data analysis environment, provides a user-friendly and feature-rich environment which already allows for construction of very rapid post-processing workflows and also scripted post-processing workflows. However, we always aim to improve things further, and in this release we have added a number of small modifications to our post which aim specifically to streamline and speed up operations which are small operations, however, which users perform very frequently. Let us have a look at some of these. And let's start with the editing of the source curves for the calculation. Consider a typical scenario where we are comparing a response of the model, for example, torque response of the model, and we are cross-plotting the target torque coming from test with the initial state of the model and the final tuned state of the model. In these cases, it's usually convenient to plot the difference between the target and the initial state and the target and final state. And in our post, this can be easily done through calculation curves. So what we have added in this release is now it's easier to actually copy and modify a calculation curve. So for example, here we have cross-plotted difference between target torque and the initial torque of the model, and we can copy-paste this calculation curve And for calculation curve, simply edit the source and change the source without changing the whole calculation. And easily cross-plot the error of the initial state of the model versus the error of the final state of the model. Our next enhancement concerns the order of the files in our post file panel. From this release, it is possible to change the order of the files in the file panel. This speeds up bulk generation of curves. For example, in this case, we're running several builds of the engine, and because the simulations were started at the same time but didn't finish at the same time, the order in which the files were loaded doesn't match the order of the builds. In the previous releases, if the customer wants to actually have the legend following the order of the builds, this is possible, but it would necessitate changing of the order of the curves one by one. From this release, it's possible to arrange the files in the correct order after they have been loaded, so from 1 to 5. And once this has been done, we can bulk plot, and the plots will be in the correct order, in the order of the builds, saving us time on arranging the curves. Our final productivity hack is for the customers who are doing acoustic analysis. In these cases, frequently sessions contain a number of actual sound generated files from microphones configured in the simulation. And as we're progressing the simulations and changing the builds, it's always possible to reload the data and keep your exported sound files the same. What we have added in this release is a simple button which allows customers to quickly export all the files, sound files, in their session in one go. And that saves customers time on actually going through their sound files and exporting them individually. Apart from the demonstrated features, customers will benefit from a number of other enhancements and corrections in WaveRT and associated GUIs, tools and utilities. Highlighting a few key ones in Wave, there are 3 changes which improve modeling for rotary engines with leakages. First of all, heat release calculations now account for leaks, providing correct post-processing output for heat release when orifice valves used for leakage modeling are open during the combustion event. The trapped quantities are now recalculated at the start of combustion, which makes these quantities more accurate when leakages lead to changes in species between the intake valve closure and the start of combustion event. Finally, we have provided a new set of summary variables based on the trapped state at the start of combustion, which help diagnostics when trapped quantities at the intake valve closure differ from trapped quantities at the start of combustion because of leaks. WaveRT now includes licensing for hardware and loop applications, and our customers can contact our support desk to obtain a license file for their hardware and loop machines. This change improves security of WaveRT solver, which has become increasingly necessary as hardware and loop vendors use standard Linux operating systems more and more. There are 2 new actuators supported in WaveRT: duct length actuation, which is possible in Wave and which can be instrumental for adjustments of intake manifold, as well as burn fraction at completion actuator, which improves control of prescribed combustion models in real-time applications. Other notable enhancements include user libraries auto-connecting RT sensors and actuators as well as source elements when added to a model in RDesk. WaveBuild 3D features new functionality for body volume check on import, which simplifies the way in which users troubleshoot the incorrect CADA models. There's also a new set of icons for WaveBuild 3D, WavePost, WaveMeasure, and WaveBuild, which simplifies differentiating the files for legacy GUIs and preprocessing tools in Windows Explorer. Finally, in our post, we can now easily configure the default x-axis for our RDesk tuner optimization datasets and set it, for example, to use a parameter which simplifies creation of plots for users who prefer to use engine speed, for example, as the default x-axis. We're coming to the end of our presentation, and as usual, let's have a brief look back at the key features of the previous release. In 2024.2, we have added dedicated support for rotary engines through a special element on Wave Canvas. We have also added the ability to impose controlled pressure drop on ducts, as well as sample sensors at specified crank angle. In functionality category, there's also a new diesel predictive combustion model for NOx. The user experience enhancements in 2024.2 featured a number of case-stable usability improvements, and the workflow changes in 2024.2 included a new coupled optimization process with Mode Frontier Optimizer, as well as automated remeshing of 3D components and a new PID calibration tool. Thank you for joining us today for the presentation on new features in 2025.1 Wave and Wave RT. I hope that this session provided valuable insight into the latest enhancements in our 2025.1 release, and if you have any questions or would like further information on how our products can support and enhance your work, please reach out to us. You can contact us at support@realis-simulation.com. We're looking forward to discussing with you how these improvements, as well as other features of our software, can contribute to the success of your modeling projects.